Yes, Gitesh, I think many things are clear to you now. Yeah. Did I give you the notes, guys? Huh? Did no? Okay. Okay. I'll give you the notes in some time today only. Okay. Let it get open. So this was my array list program. Okay. Now in array list program, we did many things. Let me close all. We did first program, see this, okay, to understand the non-generic, that is heterogeneous elements added in the array list, and this is generic, which is a homogeneous element added in the list. Then we understood many methods, contains, index of, last index, how we will access every element of the array list and present on the screen, that also we checked with the different variation. The first variation is that for each loop. The second variation is iterator from collection interface. And then third was the list iterator from list interface. Okay. And the list interface was going in the forward direction and the backward direction, isn't it? Okay. Then what we did? Then we used the array list for all the other methods. We understood about the get, set, remove, contains all, remove all. Then we also created an integer array and converted the array list into the integer array. Yes? Okay. Then what we did? We used the sorting process of array list. We also sorted the array list, isn't it? Yeah. So any confusion till here? Did you find any confusion? Anyone? No confusion, no? Everything you understood yesterday? All of you? Please let me know if you have any confusion. Still, I can see members are getting. For keywords only, we use reverse order. Yes. For reverse, you will use reverse order. Yeah. Okay. Yeah. Any confusion? No, na? Should I go to the next part of list, that is linked list? Yeah. So we will create the same program for linked list. Nothing you have to do. Just you have to. Okay. You have already written these two codes. Just place your cursor to A1. Control A, copy everything. Control C. Control A will select everything. Control C will copy everything. Go to list program. Okay. Create a new class A3, and then you paste everything here. Control V. Okay. Now what you are supposed to do, you have to erase this package and all these import statement, cut. Control X, place the cursor here. Control V. Then erase this class name because the class name is A3, isn't it? And then yes, then just check at the end also. Okay, so an extra bracket is given. So what we will do here, okay, now what you are supposed to do, instead of array list, you will put linked list. Okay, linked list. And here also make the changes accordingly. Linked list, here also linked. Okay, let me copy this linked. Okay, then go here, select array and place linked list. Select array, control V, linked list. Anywhere else? No. And then what we do here, when we are printing anything using array list. So don't print array list, print linked list. This is also select and control V, linked list. Here also select and linked list. Here also linked list. Here also linked list. So everything is linked list. Okay. Let me show you. Okay. These all outputs we are getting from the linked list. Okay. Yeah, we will talk about that only. Then if we are using the same thing for array list and same thing for the linked list, then what is the difference? Yeah. But before getting to know the difference of array list and linked list, we will do one more program. Okay, let's do the second program also. Then we will get to know. Okay, yeah. So this program also, Control A, Control C, then create another program. Sorry, another class, A4. Okay, A4. Okay, and then we will make everywhere the changes you can do quickly. Yes, you have already written the program. So delete this package, cut all the import statement, okay, and then place it before the class name. Delete this class name, we don't need this. Okay, and then place everywhere linked list. Oh, we have already copied. Sorry. Okay, linked list. Here also linked list. Here also linked list. Linked list. Okay, here also. The working is little different. Okay, I'll tell you what is the difference between array list and linked list. Okay, and then yeah, done. And everywhere you can change like linked list sorted. Anywhere else? Yeah, linked list. Okay, now let me show you the output. Okay, now when I told you about the array list, you remember I told you that it stores in the form of array, dynamic array. Do you remember yesterday I told you the difference I'm telling you between array list and linked list, okay? I told you that there is the initial capacity of array list is 10. So when the array list is created, okay, then the array format, dynamic array actually is created. So this is 10, isn't it? 10 capacity will be given 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this much. But again, if we write 11th element, what will happen? Again, more 10, more 10 blocks will be added, isn't it? So dynamically, you can see that array list is using internally a dynamic array to store its element. Yeah, isn't it? You can see, no? Then again, after 20 elements, 10, 10 capacity, 10, 10 capacity, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, if 21st element you are entering, what will happen? Again, the, you know, 10 blocks will be created again. So dynamically, it is working on the basis of what? Internally, it is using dynamic array to store the elements. But this is not the case of linked list. Okay? The linked list use the concept of doubly linked list. Okay, how that is done. So what is the concept? How basically it is used? Now the linked list uses doubly linked list to store the elements. So what is this doubly linked list? How we will get to know about the concept of doubly linked list. So when we talk about the doubly linked list, you understood this array, but linked list will have the address part and the element part. So linked list, this is array list. Okay, this is array list. Array list. But the linked list is like this. Suppose if I'm creating a linked list, so one element will be there. This is one element, but this element will be categorized into three parts. Should I make it more big? I can write the data. This is the first element. Now in the first element, this categorization, this element is categorized into three parts. So here the first part will have this the previous address. Okay, address of the previous element. And then here it will have the object or element. Okay, and this part will have the address of the next element. What is the address of the next element? So this is also address, ADDRE, address path for the next element. Okay. So right now the first element is not, this is the first element. Yes. So address part is right now null because it is not holding anybody's else address. But suppose if I create here another object. Okay. One more object I have created here. Okay. Now, then this object, what's happening? This object will also be categorized into three categories. This is full data structure I'm teaching you guys. This is full data structure. So now here, oh, so sorry, I've used this. No? So this is also address part, element part, and address part. Okay. So this is my address part. It is keeping the address of the previous element. We have already created the previous element, and this is also the address part. Okay. Address part. Okay. And here we have element. Okay, so how it is used basically. Now the address of the previous object will be stored here. Okay, so the address of the previous element is stored here. Understood? And of course, the address of the next element will be stored. So how it works actually? So this address goes to this part actually. Oh, sorry, by mistake I did this. The address part is going here, okay, to the element, and this address part is being pointing towards here. Yes, if we create another one, then this will point to the next one, and the previous one will point to the, it means this address part is pointing to this address. Understood? And sorry, this address is pointing to this address, the next one. Okay, and this address is pointing to the previous one. This is pointing to the next. It is linked here with the address of the next element, and it is also keeping the address of the previous part. Yes, it is linked with like this. Understood? So this is how it works on doubly linked list concept. Doubly linked list is a linked list which has the address of the previous element and the address of the next element, both ways. Okay. One more very important concept is that array list is little slow in manipulation. If they are performing any manipulation, no, CRUD operation, it is slow. And linked list is faster because here we create nodes. These are known as node. This is node 1. Okay. There we create blocks. No, this is node 1. This is node 2. Okay, this is node 2, and so on. Okay, so linked list is faster as because it is node based. Okay, so it is not shifted again and again, but array list shifts. Okay, this is a very important concept that you must know. Okay, and the array list will always create or implement list, but linked list will implement list and queue, because we will see linked list in queue also, how we can use linked list as a queue. Okay, so it will act as a queue also. Instead of instead of list, it can be used or as a queue also. It can be used in a queue data structure, but array list can be only used in the in the only list. Okay, fine. So now what else we can know that of course this is, I think this is more than enough for you to know the difference. Did you understand the difference, guys? Yes, the mechanism is most important. This mechanism is most important. So is it clear? Okay, fine. So I will send you the notes in some time. Okay. What we are supposed to do now? Did you do the changes? Did you do these two programs? Quickly copy paste and do the changes. It won't take a lot of time, isn't it? Node 1 and 2 was interconnected. Yes. Yes, they are connected with each other. Okay, because it is linked, the list which are linked. Okay, so how it will get linked with the address? Okay, if you understood the meaning of the word, you will understand. Data structure is really very easy, like caching. Yes, yes, Manikandan, that is little different. Caching is little different. Okay, but yes, similarly, similar. Okay, not very similar. Okay, you are talking about caching in C hash or in Java, Spring Boot. Then what? Catching is in every language. It is in Java, it is in Hibernate, Spring Boots, C hash. It is also called C sharp. Element in node 1 to address 1 and node 2. Can you explain? Yeah, of course I can explain. So I'm trying to say that this address will be null. Why? Because before this there is no node. So this will be blank. But the next address part will be of the next address. So this is the address of this element, isn't it? This is the element of this address. This address is not keeping the previous address. Now it is keeping the address of the previous part. Okay. And this is keeping the address of the next part. This is how doubly linked list works. Always. Okay. So if you want to understand the doubly linked list, no, you have to understand the work. It is a doubly linked list is a data structure. Okay, that has reference to both the previous and the next node in the list. Reduce storage of element and time for execution or speed. Yes. Ah, it is the array list works very slow. Okay, not very slow, means slow. Okay, but the linked list works very faster because it is in the form of. So this will keep, let me tell you, this will keep, yeah, that is caching. Yes, Manikanda, I agree. So this will keep the address of the next element. And this will keep the address of the previous element. This is how it works. Okay, then if we have another node, it will keep the address of the next element, and the next one will keep the address of this particular element. It works like this. Okay, so when you go to doubly linked list, when you go to data structure, you will understand the whole concept. Doubly linked list is important. And yes, somehow it is like catching only. Yeah, I do agree. Okay, but you need to know that it's a technique where your object is your application. Okay, where when we create the object, it is stored in temporary storage. That is your cache, isn't it? Uh, Cache is like see, one example I'll give you. Very good example, so everyone will understand. When you go to MS Word, Microsoft Word, just a second, let me complete. Yes, Chetan, you have any question? No? Okay. Once you go to okay, once you go to MS Word, yes, you go to MS Word, like suppose if I go to MS Word. Hmm. Microsoft Word, MS. Let's open this MS Word, okay? I will take a blank workspace. Yes. Now here, if I write Swati, okay, and I select it, okay, and I cut it, suppose. So when I cut it, where is the data gone? Where is the data? Huh? It is gone to a temporary storage area that is known as clipboard in document, isn't it? You must have heard clipboard. Yeah, we have clipped the data on the board. So it is not a proper memory, it is a temporary storage memory. Okay, it is like we are keeping it there for some time. When we originally place the data here by control V, then the data from the clipboard will be pasted here. So that clipboard is what? It's a temporary storage area. So catching, when you are learning, that catch is a temporary storage area. Yeah, to store your object in the application. Isn't it? Now is it clear what is catching? Is it clear? That is what is catching. Okay. So every technique has a very easy example in your computer. Okay. When initially I used to explain, the networking operating system. Okay. So all these concepts we had to teach with full specification. Understood? With full specification, how, what is this? Even we have to specify the whole concept of clipboard. Understood? So when you talk about caching, it is different type. Okay, because technically when you are using the caching process, that is storing and accessing data from a cache. And from EEE branch, if I need to develop na need DSA, yes, Manikanda. Yes. If you want to become a developer, you need to learn the data structure. Yes. As a developer, I can't say no. Because initially, when I was a developer, initially when I started, I completed my advanced Java and I thought, oh, I'll become a very good developer. But the algorithms for creating your concept is very important. Very important. The relationship which we have to show between entity and the different entities, that is very important to understand. So for that, you need to create a proper algorithm. But if you are not able to enhance it, create it, because there are very many variation. If you're creating an application, it is not just you are creating application for the time being, you are going to enhance it also, isn't it? If I'm creating WhatsApp, I have given only the message writing. But later on, if I want to enhance, like I want to add video calling, audio calling, but we have not specified our application in such form. Yes, we have not used more and more processing, more and more methods, and more and more enhancement, then that application will be limited. No, what happened to Orkut? You know Orkut? Do you know about Orkut? Anyone? You must be knowing. Yes, what was Orkut? It was an app. Yes. Why now nobody uses? Why? Huh? Does it exist? No, it was dissolved, I think, in 2014 itself. It is outdated. Yeah. Okay. It was the part of Google only. You know that? It was a social, what is that called? Networking service. Not Gmail. Orkut, I'm talking about. Gmail is in working. It was a social networking service which was owned by Google. It was operated by Google. Yes. Okay. But then later on, I think I don't remember exact which year, but booming is dissolved. Yes. So this Orkut was also dissolved in 2014, or I think 2014 only. But exactly which month I don't know. I don't remember actually. I have gone through all these specifications, but I really don't know why it was dissolved. Why? What was the reason? Why it was a failure? The speed was very slow, very slow. Yes, I had the ID on Orkut. Yes, they had less feature, and the features were really complex. You have to learn a lot of things to use. Okay, and the encapsulation which we learn for safety of the data security was very less. The privacy was not at all there. Yes, and the upgradation was not there. Yes, some of the upgradation was done. They updated somehow some portion. Now just see how the Facebook has got updated. Yes, did you see? They have, I don't use Facebook too much, okay? I don't have any ID now. But yes, Facebook, they have changed a lot. They have created so many new things. Yes. Okay. And in now Facebook you are using for your business opportunities also, isn't it? Some these groups are created, for this purpose, for that purpose, isn't it? In Facebook nowadays, Facebook is also very much in use because of the opportunities, business opportunities. It's a marketplace. But these all was declined by the Orkut. Yes. Okay. That is why it failed. That is why now it is not in demand. No, the user did not prefer to go to Orkut. Understood? So there are so many things you will learn in, when you create a application. So for creating an application, you need to know all the specification, enhancement, how you will bring the changes, updation. You remember SDLC, System Development Life Cycle. I think all the testers must have learned that. Even we are developers, but yeah, we have to go through everything to understand. So SDLC life cycles tells us the whole overview of the development life cycle, isn't it? Yes, it's a process which is used by the software industry. Of course, through that we design, we develop, we test the high quality software. Yes, so there are seven phases, isn't it? Yes, we have learned seven phases. First, you have to plan the project, then you have to see the feasibility, yes, the requirements, you have to gather the analysis, the requirements. What is feasible? What is the possibility to create your application? Then you have to see the design, then you have to see the coding and implementation, then you have to test this, then you have to develop it, and then you have to enhance it through maintenance, isn't it? So that maintenance part was, somehow not occurring in the Orkut. That is why it was a failure. Hmm? Yes. So if you create any application for designing, for coding, for enhancement, for the seventh phase, that is maintenance, you need to make your application perfect, and that you can do with the help of data structure. DSA is a very important concept. How you will analyze? Yes. So please, if you are going through now you are satisfied with my answer. I know you are. Yes, I know everyone get satisfied by my answer. Okay, so that convincing power should be there, isn't it? Okay, but yes, this is the truth. This is the truth, actually. Okay, not the convincing power. This is the truth. Yes, magic. No, no, there's no magic, guys. I'm showing you the practical knowledge. That is not magic. That's a practical knowledge which you understand. You have the ability to understand. You all are grown up. You know the consequences, the pros and cons. You know how whatever ma'am is telling, the same way it works. Because we have worked, no, as a developer. So we know. Yes, the person who is not in this industry, okay, ask them, they won't be able to tell you these phases of SDLC and how actually it will work. What will be the specification? Yes. If somebody asks me Hindi literature, I'm very good in Hindi. But if you ask me everything like little bit I remember, upsarg, pratyay, samas, or if you ask me any grammar portion for is Sanskrit or Kannada or any other language, it is very difficult for me. I also have to learn it, isn't it? Yes. So once you're good enough in a particular concept, you will understand. Yes. So this is my life cycle. Okay, from 16 years I'm roaming here in the in the software industry only. So that is why I know. Yes. Fine. So now you understood the difference between array list and linked list. Any confusion? Got it? Shall we go to the next part? Yes, tell me. Okay. Did you all write A3 and A4? Please make the changes accordingly. Hmm? Okay. So now what we will do, we will go to, I told you that linked list can be used as, DQ. There was a DQ option also, no? So linked list can be used like that also. So let me show you that, the Q part of linked list. Okay. A5. Now, integer we were taking, no? Should I take linked list, generic linked list as string type? Should I show you with string type? Linked list allow duplication. Yeah, linked list is a part of list, no? So it will allow duplication. It will have the index concept also. Okay, fine. Okay, so let me show you linked list. Okay, so now we will be creating a linked list. One is equal to new linked list. Right now I will create an empty linked list. Okay, and then we will add, let's make it generic type. Okay, so here I will add only string type of object. So this is my generic type. Okay, homogeneous data we are going to add. Let's add, and here I will show you duplication also. And after adding the data, you can see that it is maintaining the insertion order. Let's add a name, Ravi. Yes, make it capital R. First letter of the name should be capital. Let's add here other name. Okay. Let's add something which is different. Okay, so we can later you can sort it also. Yes, and then we will add. Let's add here dot is L1 dot add. Let's add here Harsh. H capital. Let's make it a capital H. Yeah. So I have added so many names, isn't it? If I try to print, okay, L1, it will give me, first you will see it will maintain the insertion order, okay, index wise. Is it maintaining the insertion order? Yes. Now let's see duplication. Suppose if I want to add duplicate elements, okay, so let's add this Sunil, okay, duplicate element. Let's add more duplicate element. Let's add Harsh also. Okay, let's add Virat also. Okay, so we are taking 3 duplicate elements, but it will always maintain the insertion order. Yes. Okay, so now linked list has its personal methods also. Okay, those methods are like first element, finding last element, okay, removing the first element, removing the last element, adding the first element, adding the last element. And because there is duplication, then it can also remove the first occurrence, it will also remove the last occurrence. Means if any object is occurring more than one time, yes, then I can delete the first occurrence of that object, or I can delete the last occurrence of that object, because here duplication is there. That is why. Okay. See, I forgot to tell you retain all method. Okay, I'll tell you retain all method here. First, I will show you all the methods. Okay, so here if I want to add, you got to know that at the 0th position, Ravi is there. But before Ravi, if I want to add anything, in linked list, we have a method add first. So L1 dot add, you can see add first. I will add, let's add some girl's name like Amrita. Okay, these are all my students' name. And L1 dot add last also. We can add at the last also. The last one, okay. Let's add this. Okay. Now, if I want to see the first element and the last element, I can use another method, get first and get last. Yeah. So I want to see the first element is equal to, so here if I write L1 dot get, yes, I was correct, get first. Okay, and then here I will write first element and the last element. Okay, so MENT. Okay, so here plus L1 dot get last. Okay, so here get last. Let me show you what will be the first and last. Of course, we have added the first and we have added the last. So first element will be Amrita and last element will be Shweta. Okay, yes, got it. So these methods are there. Now, if you want to remove the first and the last element, then also you can use remove first and remove last. L1 dot remove. Yes, can you see remove first? Yes, and if I want to remove the last element, we can use remove last. Okay, this one. Okay, so after this, if I try to, okay, after printing this also, let me show you the whole list, okay, whole linked list. I'm not in the advanced Java phase. Okay, L1, and let's go to here for L1. Okay, so here it will show you the first element and last element. But here it will show first element as Ravi and last element as Virat. Okay, let me show you. Yes, can you see? We added the first element, we added the last element. But later when we removed, the first and last element is gone. Yes, understood? Then we have remove first occurrence and remove last occurrence. So we have to give the object name. So we have used Sunil 2 times. No? So let's remove the first occurrence. The first time when Sunil is present in the list, that first object we will delete. Okay, so how we will remove first occurrence. So here, if you want, you can display also. Okay, we can also simply write L1 dot remove first occurrence. Okay, remove first occurrence, and you can write the object name. So let's write Sunil. Okay, if you want, you can display it also. Okay, and then you have to remove L1 dot remove the last occurrence. So we have Harsh 2 times. So when Harsh is last, whatever is the place of the last time Harsh is printed, so I will give that object. So let's write Harsh. Okay, so Harsh. Okay, now we have given the name, remove first and remove last occurrence. So it will delete the first position and first, second, third. So 0, 1, 2, 3, 4, 5. Now it will delete the fifth position. After deleting Sunil, the Ajay will come at the first position, isn't it? So 0th position, first position, second position, third position, fourth position, fifth position. So fifth position will be deleted. If I delete Sunil, then Sunil will be deleted and all the others member will be shifted to the one above index. Okay, you have to understand it shifts automatically. Can you see? Yes, here Amrita was deleted. Then oh, sorry, I didn't show you after this. After deleting, let me show L1. Okay, so anything else I'm forgetting? Remember. Yeah, see, Sunil is deleted, no? Yeah, from here. And this Ajay is shifted here. This Virat is shifted here. This Harsh is shifted here. Sunil shifted here. Then this Harsh was, sorry, deleted. And then we have Virat here. Yeah, got it? Any confusion in this? You can take the screenshot, guys. Once you feel like that, no, ma'am, we want to write the code, you can write the code. Hmm? Okay, yesterday I forgot retain all method. Retain means suppose there are two linked list or two array list and they have similar elements. You remember set theory from 9th and 10th standard, the union and intersection. What was the intersection in the set theory? You remember? If you remember. How many of you remember set theory from 9th, 10th standard? Yes. So we had a concept in the set theory with union and intersection. Isn't it? Am I correct? Yes, you remember? So what was the union means same element? Same no, union means all element. Element from A, element from B, everything. Intersection means common element. Yes? Union means all element. See, you know now? Very easy. So try to, whatever you are learning in Java, no, you try to match up with whatever practical knowledge you have learned in other subject. You will understand the concept. Because for everything, I give you an example, isn't it? And does it make it very clear? So, what is you have already learned, you try to match the concept with learned concept, what you already know in your real life, in your practical life. Then everything will be very easy. So, the retain all method is behaves like intersection. Okay. If I have, suppose this will work for array list, linked list, all the list type. Okay. So suppose if I have to create a linked list. Okay, let's create linked list. Okay, but I'll give some other data. Hmm. Okay, let me make it L2. This is L2. This is L2. Should I write some other name? Write what should I write? Okay, let me write Monday, Tuesday, Wednesday. Huh? Monday. Let's write here Tuesday. Okay, and let's write here Wednesday. Wednesday. Okay. Then let's create one more linked list. Okay. So this is my another linked list. Linked list L3. This is L3 dot. This is L3. L3. This is L3. Monday, Tuesday, Wednesday. And let's change something. No, let's make Thursday. I've not written. No, let's write here Thursday. Thursday. Okay. And let's write here Friday. And let's here write Tuesday. Okay. Now tell me what are the elements in the L2 and L3 which are common? Which are common? Tell me. What are the objects or elements which are common in L2 and L3? Monday, Tuesday. Only Monday and Tuesday. So if I try to retain from T2 dot, I will retain L1, sorry, L2, sorry, L2 dot retain all. Okay, so it retain only the elements in the list that are contained in specified collection. Okay, it will remove from this list of its element that are not contained and specified in the collection. So retain all L3. If I try to display L3, if I try to display now L2, what will come? If I try to, because we are retaining the elements of L2, okay, L3 in L2, which are common. So if I try to print now the L2, what will be displayed? Monday, Tuesday, because they are the common elements in both the linked list. So this same thing you can do in array list. Yesterday I forgot. Just I got, when I was doing this first, I saw this retain all method when I was writing this, when I was selecting this. So I thought, oh, I forgot to tell you retain all. Okay. Yeah. You can take a screenshot for this. If you want to execute, you can execute. But A3 and A4, you will do it yourself. Just you have to copy paste and change linked list. I'll give you 10 minutes, finish this code. A3, A4, you will do it yourself. Okay. Array list of sorting we have already done. Yeah. Then we will go to vector and we'll try to finish stack also today. Finish this code. Finish. A1 to A5. Yesterday you did not write A1. Huh? Quick snapshot. Okay, fine. So quickly take A1. Take the screenshot of A1. Hmm? Let me scroll it down. Take the screenshot. Okay, let me go to the next part. Take the screenshot. Okay, let's go to this part. Let's go to A2 now. A2. This is A2. Okay, let's go to the contains all. Yeah, contains all. Let's scroll down. Okay, this is reversing in the ascending and descending order. So the same thing you can write for the string data, for the character data, for the float data, everything. You can use the same method, same way. Okay, if it is integer, if it is character, if it is string, if it is any data. Okay, fine. Let's go to A3. A3 and A4 is replica of A1, A2, but just change that we have used linked list. Okay. I'll just scroll down. Okay, let's go here. Let's go down. Excuse me. Let's go to the accessing of array list using iterator, list iterator, and the backward direction also. Okay, so you can perform this in linked list. Let's go to A4. Okay, please take a screenshot. Okay, let's. Hmm. Okay, let's go here. We are converting the array list into array type. Okay. For integer, I've used integer wrapper class. For character, you will use character wrapper class. Okay. So accordingly, you can create different. And then we are sorting the linked list in ascending and descending order. Okay. Clear? Yes. Done, Abhishek? Now A5, I want you all to execute. At least execute one program. Yes. Do it. Done, Abhishek? Did you take the screenshot? Welcome. Start the code, everyone. 10 minutes, finish it up. A1 from first part. First you finish this, then I will show you A1. Okay? First you finish this code, then I will show you A1. Anyone who is new here in this batch? Your batch. Okay. Let me know if anyone has started the class from yesterday or today. If anyone has joined this class. Okay. If you want me to scroll down, please put a message here. If I'll see the when I'll see the message, I'll scroll it down. Yeah. Complete this. Should I scroll down a little bit? Hmm? Guys, should I scroll down? Yes? Okay. Yes. Please finish it up. Finished? Shall we go to the vector? Okay. So for vector also, vector is also basically, done. Okay. When we talk about the vector, vector is also a part of the list also only. So it will follow all the specification, all the characteristic of the list. Okay, nothing is there which it will not follow. Of course, it will follow everything. It will follow the index, initialization of the members. It will follow. It will maintain the insertion order. It will also predict. No, why it will be deprecated? First, let me tell you, okay, vector was actually initially only created, okay, before the collections, okay, but later on it was made as the part of the collection, okay. It was a legacy class, yes, because it was before the collection, okay. So now it is a part of collection, okay. So vector will follow all the features of the list. Okay. Basically, when we talk about the vector, okay, the main feature of the vector is that vector has its own method for adding the element, for removing the element, for performing all the other tasks, for accessing the element. Because the collection was not there before, no. So the vector came before the array list collection in 1.0. Okay. Later in 1.2, it became the child of collection. So it has its own method like add element for adding the objects. It has another method remove element for removing one object. If you write remove all element, then it will remove all the elements from the vector. For accessing, it had a method which is known as element at. So you want to search for an element at particular position, then you go for element at. You can also use first element, last element method. So it will show you the elements at the first position, element at the last position. Okay, so vector was beforehand it was there, okay, in the in the data structure of array. Later on it became the part of the uh, this collection. Okay, now vector also has a default capacity of 10. Okay, the vector also has a like how array list capacity is 10, initial capacity. So the default initial capacity of vector is also 10. Okay, the default capacity of the vector and the amount by which the capacity should be increased will be creating the whole concept. Okay, so the sometimes they ask the capacity for array list also. Sometimes they will ask the capacity of the vector also. Okay, so vector was already there. Now you already know how array list works. Okay, so vector is also somehow like that. Fine. So let me show you a program from vector. Vector is very less asked. They don't ask program for vector. No, there is no formula. Okay, there is no formula. In the data structure, when we go to the vector part, okay, it's just like that one by one by one, it will be added. Okay, when we insert the element into vector, it is inserted in the index, just index form. Okay, later on, when you go to the data structure part, you will understand a concept which is known as array copy. Right now, I won't tell you that. Okay, that is because it is data structure. We should keep something for data structure, isn't it? Okay, so once you go to the data structure part, no, you will understand many other concepts. Okay, but for stack, I'll tell you one concept. Okay, when we started working with vector, okay, it was the initial part, means before the collection. So right now they don't ask much vector, they ask linked list, array list. Okay, and all the methods which we have used in array list and linked list, everything you can use. So vector is not too much in demand right now. Okay, array list and linked list is, they ask the, for the freshers they ask array list and linked list, but it does not mean that you will forget vector. You have to learn a vector at least a little bit. So what we will do, let's create vector. You can do all the task of vector as you have done in the other two classes. So what we are supposed to do, we will use add element method. I'll show you the first element, last element, element add, everything. So A6. Okay, okay, so let's create here vector. So we have to import vector also from util. So import java.util.vector. Okay. And then let's go here. Let's create the vector object. Vector, to create a vector, we need a vector class. v1 is equal to new vector. Yes, and right now empty vector I have created. Let's create first non-generic. Okay, then you can create generic. Non-generic. So in non-generic we can store different kinds of element. Okay, so v1 dot, it has vector has a method which is known as, it belongs to vector, which is add element. Okay, so this add element will add the elements starting from the index, because vector is a part of list, so it will follow the index. Let's go for the help. Okay, then so this will be printed at the 0th position. v1 dot add element. Okay, let's go to the add element part. Then we can add a boolean value. Okay, it's a non-generic. v1 dot add element. Okay, then let's go to some numeric value. v1 dot, sorry, dot add element. Let's go to add some float value. Okay, then v1 dot add, let's add some double value. Okay, 6.55. What else we can? Character we have not added. Let's add a character. v1 dot add element, and let's go to the, okay, we have added all the different types of object. Now if you want to see the elements, then you can simply print. If you want to see the size is empty method, everything you can display here. Okay, so v1 dot size, the total number of size will be of, okay, so let's go. Okay, size is 6. Okay, now if you want to see only the first and the last element, so you can use that also. I want to print the element at the first element, and I want to also print the element at the last, so v1 dot last element. Okay, so it will print first element hello, last element hello. Okay, okay. Now at a specified position, if you want to find the element, so we have element at v1 dot element at particular index. So let's give index as 3. So third index is 0, 1, 2, 3. So you will get this value. Okay, the float value. We are getting the float value, isn't it? Okay, now what we can do, you can add the duplicate elements also if you want, because it is list part. So you can add duplicate element. You also saw that it is maintaining the insertion order. Let me show you that it will keep the duplicate elements. And you see it is, it is preserving the duplicate elements. Yes, understood till here. Now you can create a vector of, generic type, and you can perform all the tasks. So let me go here. Let me copy everything, and let's go here. So what I will do, I will make some changes here. Okay, so instead of array list, I will make it, okay, this is vector. Okay, and here also let's make, so this is generic type, isn't it? I will not use all this. Let's delete this one. Okay, let's delete array list also. These two we need, iterator and list iterator. Okay, so let's use this. Okay, and then we don't need this part, these two. These we don't need. We already have seen the generic part. Let's see the non-generic. Okay, so now in non-generic, I've used vector of integer type. Okay, these are the elements. Okay, and then here you can see contains method. Okay, instead of a1, let's take a2, generic type. Okay, no, we have v1. No, that is why it was giving error. Okay, a2, let's make this v1. v1. Okay, a2, let's make this v1. Okay, let's, anything else? Okay, instead of array list, you write everywhere vector. See, you can use, no need to write the whole code, copy paste, because it works the same. Method, what do ma'am? I didn't get you, Manikandan, what you are asking. All the methods which we are using in array list, we can use in the vector. Okay. Add all, yeah, that also you can do. You can copy paste the next one also, and you can write here. Okay, this one also, these all you can use here in the vector, all these. Okay, all these things. I think we need to change the reference variable. Yeah, instead of array list, take, also you take vector. They are siblings. Vector and array list are siblings. Okay, a1, a2, we've already used a2. No, let's make it a3. a3, 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 A3. Let's make it A3. A3. Let's make this vector first. It's also this also A3, 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 3. A3 and make it A4. Okay, array list. Instead of array list, make it vector. Okay. You can take screenshot if you are confused. Huh? Vector A4. Let's make it A4. A4, A4, A4. Sorting vector. Okay. Then A4. Okay, let's make it A4 and let's make it A5. A5 we were supposed to make. No? I'm making 4 only. A5, 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 A5. Okay, sorted, unsorted A5, sorted A5, descending A5. Yes, did everything. Okay, instead of array list, take vector. Okay, if you want to take screenshot, you can take. And anywhere else, just make it vector. Unsorted vector. Unsorted vector sorted. It's also vector. Okay, then yeah, vector, vector. Okay, done, no? Yeah, you can take a screenshot of this A6. Okay, then you can execute it later. I want to finish stack today, that is why. So from Monday onwards, we can start with set. Scroll, taken this much. Should I scroll, everyone? Okay. Sorry. Yes. Take the screenshot. Okay. Let me scroll down from index. This is not array list. This is vector. That is what I'm checking everywhere. Vector. Here also make it vector. Okay. Okay. 54 line. 54. Thank you. Because when I'll give you the programs, okay, it will show array list, array list. Yes. So today I will sit and copy paste every program and send you in the same file. The file which I've sent you, no, till string, in the same file I will store. You want all these programs today, or should I complete the whole portion till file handling and then send you the code till multi-threading and then send you again? Tell me, huh? From starting? Yes, I've sent you already, Preeti. From starting. I've sent you, didn't check the this thing, QTalk, this program you want to. Fine. So I'm scrolling it down, accessing of vector using iterator, list iterator. Please check. You got no till string. I've sent you all the program, guys. I'll send you all these programs also. Okay, wrapper class and collections till whatever I complete today. Okay. Yeah. Okay, let's go. Till last add once Send it once, ma'am. Yeah, okay. Then I will send you at the very end. Yeah. Because again and again adding into that. I have not deleted that file because I have to send you no till last. Okay. Taken. Learn everything. Okay. Learn everything. Do not leave anything. I know array list and linked list will be asked. They will ask you difference between list and sort. Sorry, list and set. They will ask you difference between list and linked list. But the thing is that you should know each and everything. You should also know vector. Okay, how the stack works. That is the data structure. Very important. I'll tell you a little bit. Hmm? Not internally, but I'll tell you about the top of the stack. So, screenshot. Done? A6 from starting. Right now, I showed you Preeti. This is A6 only. I was showing you A6 only, no? Quick, quick, fast. Okay, I'll just scroll down. Quick, fast, take. Okay, let's go down. Done or more you want, Preeti? Okay. Somebody asked me A1. Who was that person? Somebody asked me to show the first one, first program, A1. Isn't it? The one who asked me to show A1. Take the screenshot. Welcome. Somebody asked me, ma'am, show A1. Isn't it? Take the screenshot, please. Where are you? Taken A1. Yes, taken. Ah, Shubhakanta. Did you take this screenshot? You want more screenshot? Okay. You want me to scroll down? Shubhakanta. No, done. Okay. Shall we go to see the stack part? Yeah. So when we talk about the stack, guys, stack is subclass of vector. It is the child class of your this vector. Okay. And the most important part of stack is that it is specifically designed for first in, last out. Okay. Okay. For first in, last out. Okay. And it has three important methods: push, pop, and peek. Push method is used to insert an object, okay, to the stack. I think in core Java you must have learned this, isn't it? The push method is used to insert, add the object into the stack. So why we say instead of add, we say insert? Because we insert it on the top. There is a concept of top in the stack, that also I'll tell you. Pop method will remove as well as also display. It will return also the top of stack. And peek is it will return the top of the stack without removing it. We peek, which is the element at the top. Okay, so how to implement the stack, it is very important. Okay, so basically when we talk about the stack, the concept of little bit information I'll give you here. When we talk about the stack, okay, in stack there is a proper point of top. Okay, see, when you go to advanced part, serializable, clonable, iterable, collection, everywhere you will find this. Okay, so how to create the stack, let's know that. Okay, now the most important part, the processing of this is that we have three methods in the stack. Okay, the first method I told you is push method. Push the object. One object we will provide here, isn't it? One object we will provide here. Then we have the pop method. So pop method will delete the element which is at the top. It always delete the element which is at the top. So what is that top? We will understand the concept of top. Then we will check the element which is going to be removed. So what is this peak? Okay, to understand, you can say it checks, basically you can say first in last out, or you can also say last in first out, LIFO. Okay, or philo, whatever you want you can write. The last in is the first out. Okay, so it is a linear data structure. Hmm. It is and of course there is lots of objects stored here, so it follows LIFO or philo, whatever you want to say, last in first out or first in last out, both is correct. In Java, not FIFO, first in, not first in first out. I'm saying either LIFO, or you can also say first in, okay, last out. Okay, below. Okay, the first in will be taken out at the last. Okay, so now what I was supposed to say? I was supposed to say that in this data structure, we understood push will be used to push the element inside the stack. Pop will be removing the element from the stack. Okay, now the very important part is that there is a concept which is known as top. Okay, yes, insert and delete. Yes, there is a concept which is known as top. So suppose this is it's not open, no? Okay, let me see if I can erase it. Suppose this is my stack. Okay, peak means we are just checking which is the element at the top. Okay, the element which is at the top, okay, is always removed, or if we try to insert the element, it will always be inserted at the top. Now what happens here, basically, suppose this is my object. Oh no. Suppose this is my object, this object. Okay, this object I have to put. Then this will always the top of my stack. Okay, the top always changes, guys. Okay, this is the, I'll tell you with the example. Okay, top of the stack. Okay, so now when I am putting here one value 6, then this 6 will be inserted here. So the 6 will be inserted at the top. The 6 will be inserted at the top. Okay, right now we inserted the element at the top. Yes, now we have another element. Now here I'm using another element to insert. So what we will use, let's insert 10. Okay, so what will happen when we are inserting, this element will shift down. Okay, this element will here shift down. Okay, the 6 will be shifting downwards. Okay, so the 6 will come here. Okay, and this 10 will be provided at the top. Okay, now suppose again if I want to insert another element. So here I want to insert, suppose 14. Okay, 1 4. Okay, 1, let me 14. Okay, so what will happen now? Again these two will shift, and then 14 will be sent at the top of the stack. STACK, I forgot to write, C is also there. Okay, so here let me put C and K, stack. Okay, so now what will happen? The other element will be inserted, okay, and the other already stored element will be shifted. So 6 will come here, 10 will come here, okay, and the 14 will be stored here. Okay, so here what will happen? Okay, have you gone to any marriage or any, any kind of celebration? When we go to, okay, what happens, the first plate is kept at the last, isn't it? When you go to eat the food, what is the arrangement of the plate? The arrangement of the plate is in the stack form. Or you see your call logs, when you see the call logs in your mobile phone, the first person in the morning which has called, their specification will be shown at the end of the day in the very last position for that particular day, isn't it? Yes, that is stack. Yes, using stack, isn't it? So many examples are there. Yes. So this is the top. Oh, sorry. This is the top of the stack. Okay. Now, if I want to remove the element, so what is the element which is at the top of the stack? This element, 14, isn't it? Yes, 14. So what will happen? First of all, this element will be removed. If we entering the element, first we entered 6, this is at the, then this, and then this. Hold on just a second. Okay, so we are adding the elements. First 6 will be added, then 7, then 14, and they are shifting, isn't it? But once we start to remove the element, the first element which will be removed will be 14. Yes, so once this element is removed, okay, we can also see which element is at the top to which will get removed. So peak method will be used here. So once we remove this element, okay, once this element is removed, okay, what will happen? Now the top of the stack will be this. The top of the stack will be this. Okay, it will shift upwards. Okay, I don't want to delete now. Now I think 10 I have written, no, not 7, sorry. 10 was there, no? Yeah. So now this is the top of the stack. Now if I want to remove with the help of top, which will be a pop method, then which data will be deleted? This data will be deleted, isn't it? So yeah, this data will be removed. Okay. Okay. Now, which is my top now? Which is my top? This is my top now. Yes, 6. Okay, it will shift upwards actually. Okay. So this is my top of the stack. Now, if I want to delete the data, which data will be deleted? This. So isn't it following LIFO or FILO? Isn't it? It's actually distinct. So if I delete, then my stack will become empty. Yeah, there is other concepts also, overflow, underflow, that you will understand in the concept of data structure. So I'm not going into more detail. There is a lot of use of the stack. Right now, I told you one use. One use in the application. What was that? Right now, I told you one use. One use I told you. Contact list. Yes. Can you think of more? How it can be used in application? Stack chats. WhatsApp chats. Correct. And you remember back and forward buttons in web browser? Huh? Web browser is the very long back. Insta is very new. WhatsApp chats are very new. Yeah. So how this back and forward buttons on the web browser works? And right now you were telling me, ma'am, redo, undo. What is that? That redo, undo functionality in text editors or any image editing software. How it will work? With the help of the stack. Yes. Okay. Delimiter checking also is done with the help of stack. There are so many, some recursion processes can be also done with the help of stack. Okay. With the help of stack data structure and algorithm. Okay. So there are, so memory management is also done. Okay. So delimiter checking is also done. Okay. And there are so many things which we have worked on. Yes. Okay. When you use the different expressions, when you use, for mathematical expression. If you write in infix notation, okay, so it convert them to postfix notation or a prefix notation with the help of stack. Understood? So there are so many things. I think the first example is clear. Yes, that the back and forward button, which we use on the web browser. Yeah. So that is your stack, back stack, forward stack. Yes, in the navigation of the pages. Every interface is in the util package. Yes, every. Okay. Shall we do a code for stack? My laptop is charged. Yeah. Okay. Shall we do a code for the stack? Simple. Just we will use push, peek, and the pop method. Not more than that. Okay. Because we are not studying data structure. But I have taught you this whole concept is data structure only. There is more concept. There is a concept of stack underflow. There is a concept of stack overflow. HTTP request and response is example of. Uh, no, that is not. That is not. That is you are going forward. No. Yeah, you are going forward. When you are going to the backward page or forward page, okay, then when you are using that process, that button comes here. No, here buttons come. No, going backward, going forward. That I'm talking about. When you are writing here some specification for HTTP request, that is you are going forward. So it can be a part of stack because it is stored in the stack. Yes, how it will go forward if you go for these two buttons which we use here, no, backward and forward, that is basically in the stack format. Okay. Okay, so there are multiple things which we use. Okay, what we were supposed to do, write the program. I'll write a small program. Okay, for the stack, this is the last part of the list. On Monday we will start with set. So A7, isn't it? Okay, let's start the stack. So import java.util.stack. The whole collection interface is inside the util package. So every time you have to call the class from the util package itself. Okay. So here stack s1 is equal to new stack. Okay. Fine. And this it is an empty stack. Main method I forgot to write. Wait. Okay. Now this is my stack, which is the non-generic stack. Okay. Here, if I want to enter the data, we will push the data. Push. Okay. So let's push different types of elements. Let's push hello, which is a string type. Let's push s1 dot push. Okay. Then let's push some value, boolean value. Okay. s1 dot push. Let's push some numeric value. Okay, s1 dot push. Then let's add float value. Okay, then s1 dot push. Let's add, sorry, not copying to. Okay, this is not for you right now. Okay, let's write here a character variable. Okay, so you can see all the elements are pushed. Now, this element is at the very end. Okay, and this element in util package only static method is there. Static method, scanner, no, scanner you're talking about. Oh, which static method? There are several static methods, but it is in the classes, no? That sort method you're talking about. Abhishek. Sort method, yes. But it is in the class, no? Collections class. Collections class is in util package, yes. Arrays class is in util package. So many classes are there. Okay. So what I am supposed to do here, I will show you, this is the first element which we inputted. So it is at the very end, which is the recently pushed element C. So this C is at the top. How I can see that C is at the top? So I can use, first I will show you all the elements. Okay, S1. Then I will tell you how to P, how to C. So these all elements you can see, this is the element which is at the top of the stack. Okay, so if I want to see which element is at the top, okay, element at the top in the stack is equal to, I will simply write s1 dot peak method peak. Okay, so it will give us C. Okay, this is the element. And if I delete the element, which element will be deleted? Element which is at the top is deleted first. Yes, so let's write, let's make the changes. Element, deleted element, no, deleted element. Okay, so element which is at the top is deleted. Okay, so here s dot, what I will use? Pop method. Pop. Okay, then it will show C. Okay, now which is the element which is at the top? This element will be at the top. Let me show you now the next element which should be at the top after deleting the last element. Now this element is at the top. Okay, see, if I delete, then if I delete this element also, then the previous element will be at the top. Okay, so then this element will become the at the top. Yes, very easy. This is how stack works. Understood? Any confusion? Any confusion about the stack? You want to learn anything more? How to find last element in the stack? You want to learn that also? No need to go for that. Okay, last element. Why you want to find the last element? Huh? If you want to fetch the element, then you have to go for peak only, one by one, step by step. Okay, and if you have to remove, you have to, they ask fetching, they ask removing, which you do with the pop. Okay, or the entering the element. Okay, now if you want to, they ask one more thing, they will ask you how you can use this stack for removing every element. Then you have to use whatever reference variable you have taken is empty or not. See, I'll tell you one more thing what they ask. Okay, they ask you like this. You have to pop elements from the stack if the element is present. So we use while loop and my reference variable is s1. No? Is s1 empty? No, it is not empty. Isn't it? So it will give me what value? False. No. This method will give us false value. No. Will it work? No. So I will put here a not operator. Not. Okay, not s1 dot is empty. So once it gives us false value, I will make it true by not operator. And then what I will do, one by one, I will pop every element. I will write s1 dot pop. That's it. Okay, or s1 dot peak also you can do. You can see every element that way. So it will remove also and display also every element. Okay, this way you they ask. Understood? This way they ask. Then we have other methods also. We have a search method also. Yes, it will return the position of the element. So you have to use the reference variable dot search dot element, what you are asking for. Okay, so you can use that element. Okay, suppose I want to search the element. I right now I've deleted. So let's go before. If I want to search element of before deleting, any element, let's take that. Okay, this method is taught actually in the data structure, but I'm teaching you here only because you are asking. You have to go for the search element. So if I want to check the element at the fourth position, yeah, so what we will use? We will use the reference variable s1, okay, and you can also display. Yes, I will write s1 dot search. Can you see? Search the object, not the other thing, get, contains. Okay, we have this method. Okay, so I will search the element which is at the fourth position. So what I will write? I have to write the, what I have to write? We have to write the object, isn't it? So we will write this 45. Object we have to write. Index was also there. One index method was also there. Okay, so it will provide me, okay, it will just provide me the output. Okay, so here search 45. Yes, and it gives us the 45. Okay, so return type of this was, mm, the return type will be the position, isn't it? Yes, 3 index value. We are getting 3. Okay, this is how you can search. But there was one more method. Maybe search object was there. Add all also it can use. Capacity clear clone also. And let me check once. I'm forgetting the method. Node contains copy into empty. First element, yes, first element. The all vector methods will be here inherited. Okay, first and last. Okay, that method which I'm thinking of is not here. Okay, that is not here. And all the other methods. I was thinking of one method, but it is not here. I think it is in set. Okay, so all the other methods which you have used in the previous program, you can use it here. So write down this code and what program I have given you in A6, all these. You can copy paste and put it inside the stack also. Okay, please do it. Please do the needful, guys. Complete this. Done, everyone executed. You want to take screenshot of paint also. This though I have already. Okay. And here it was 10, I guess so, isn't it? Yeah. Take the screenshot. You want to take the screenshot of all this? Array list. This is linked list. Okay, this is the way of adding linked list. These all are data structure you are learning here. Half of the data structure you have learned. Yes, array list, how does it get stored? Okay, how linked list? Yes, and how the stack. Okay, done? Okay, fine. So Monday we will start with the concept of set. We'll try to finish set on Monday full. Okay, then Tuesday we will do map. Map will be completed, I guess. No, sorry, Q and map. Monday we will finish set. Okay, Tuesday we will finish the Q and the map. And then two more classes I need for, or maybe one class for exception handling. Okay, one class for exception handling, one class for file handling. Okay, yeah, okay, and one class for multi-threading. Let me see if I can finish in one class. One class, I guess it will be finished. So by Friday or maybe Saturday, your whole portion will be finished. Okay, then I can send you all the things. Then I will take a test, proper programming as well as mock test after 3-4 classes. Okay, please start revision. Okay, fine. So let it be till here. Let's meet on Monday. Today is Saturday, no? Okay, fine. Thank you, everyone. Have a good day.